Milk is a fundamental food, especially for newborns. But did you know that dairy animals must give birth before they can produce significant amounts of milk? This fascinating process begins with changes in the cow's body as it approaches the end of pregnancy. Hormonal shifts activate the mammary glands, and the regular removal of milk stimulates ongoing production. The ideal milk production cycle starts with breeding the cow again about 90 days after calving. The cow is then milked for 10 months and allowed to rest for the 2 months before her next calving. In modern dairy farming, cows are often kept in confined lots where they're fed hay or silage, whole corn, or other plants preserved by fermentation, ensuring consistent energy levels and high milk yields. The combination of selective breeding and optimal feed has led to astonishing results. Some cows produce as much as 100 pounds or 15 gallons of milk per day. Although the American average is about half that, it's still a remarkable achievement. Dairy breeds of sheep and goats, by comparison, produce about 1 gallon per day. The milk-making process begins with the secretion of colostrum, a nutrient-rich fluid filled with fat, vitamins, and vital proteins like immunoglobulins and antibodies. After a few days, the colostrum is replaced by milk that's ready for sale, while the calf is weaned onto a diet of reconstituted and soy milks. To maintain production, cows are milked 2 or 3 times daily. The mammary gland is an incredible biological factory. It pulls some components directly from the cow's blood, but the key nutrients, fats, sugars, and proteins are synthesized within the gland's secretory cells. These cells release the nutrients into tiny compartments that drain toward the teat, creating the milk we know. Fresh milk is a living fluid, filled with active enzymes, living cells, and beneficial bacteria. However, pasteurization, a heat treatment process, reduces this vitality. While pasteurized milk is safer and more stable, traditional cheesemakers often prefer raw milk for its dynamic properties, which contribute to the ripening process and enhance flavor. Milk owes its milky appearance to microscopic fat globules and protein bundles that scatter light. The other key components of milk: dissolved salts, sugars, vitamins, and proteins. Each play a role in its unique composition. Milk is slightly acidic, with a pH between 6.5 and 6.7, and its acidity and salt concentration significantly influence the behavior of its proteins. Finally, the color of milk can vary depending on the breed of the cow. For instance, Guernsey and Jersey cows produce especially golden milk due to lower conversion of carotene to vitamin A. In contrast, sheep, goats, and water buffalo process nearly all of their carotene, resulting in nutritious but white milk and butter.